Hey there everyone, welcome back to the channel, and in this video we'll be going to discuss the problem which is rock paper scissors, which is a problem B of status 114 div 2. The problem statement is quite easy. Everyone has read the problem statement. In this we have been given that Chef and Safina has been playing a game which is rock paper scissors, and the game consists of n rounds, and both of them are having three choices, that whether they can play a move as R, means rock and paper, or scissor. So basically they are playing a game in which they are having n moves, and for each move they are having three choices, that whether they can play rock, paper, or scissor. And the rule of the game has been defined here, that if I'm playing as scissor, then in what conditions the second player will be winning, that what is the move that he or she had to be take to win the against me, that has been defined here. And the statement wants us to find a string, means we have to find a string of moves for the chef, such that the chef will score exactly, or you can say strictly greater than Shefina, strictly greater than n by 2. So we have to find a string of moves for the chef in such that the score that has been calculated based on the move of Shefina and the moves of chef that we have to find, that should be greater than strictly greater than n by 2. You have to find such a string that satisfies this condition, that the score of chef is going to be strictly greater than n by 2. And if there are multiple answers possible, then we have to find the lexicographically smallest one possible. Fine. So this is all about the problem statement, and let's see how we can solve this. So the problem statement seems quite easier, and all you have to do here is only simulation and just simple implementation, you can say. Now let's see what we can do. For example, if I'm taking this test case, like third one, that is R, S and P, means Shefina has played her moves as rock, scissor and paper. So what is going to be the possible, and for the chef we have to find the moves, like we have to find the three moves for chef, such that the score of chef is going to be strictly greater than n by 2. N by 2 means here the n is 3, means n by 2 is going to be 1, and n by 2 plus 1 is going to be 2, means chef should score at least 2 in this particular case in order to win. Fine. So for this index, what can be the possible answers? That, like here Shefina has played rock. So if chef, what is the condition to that would let the chef win? That is obviously P, because Shefina has played her move as R, so chef have to move P in order to win. So this is the possible answer for this. Fine. And we have moved to the second index. We have to find the what can be the answer for this. So Shefina has played S. So in order to win, chef should play obviously P, R, because Shefina has played S, means scissor. Then in order to win, chef have to play R, rock. And here Shefina has played R, and till this point we have scored 2, which is the required score, as you can see. So no matter what we will be playing at this position, that doesn't matter to us now, because we have already scored the required score. So we can either put P, R or S here, no matter whatever it is. So but if chef wants to win, he has to play S here, because scissor is going to be going to defeat paper. Okay, but this is one possible answer to score at least 2, which is P, R and S. P, R and S. But what if I say that also they have mentioned that we have to find the lexicographically smallest string, means first of all we have to give the preference to P, then we have to give preference to R, and then we have to give preference to S. Means if for any particular index, if we are able to put P here, then we have to put P here. As you can see here, that we have kept R here. But if we let the chef lose at this point and win at this point, then also the score is going to be 2. Then there might be possibility that if chef is winning some points here, let's suppose X is the winning points, And let's suppose for here, by putting p, means we have kept p here in order to let the chef win, and we have scored x. And for some points we are letting the chef lose. Let's suppose this is the losing point in which we are putting p and we are losing the game. And after that, here we are putting some points, means we are putting something and we are scoring the required score. In this particular case, we let the chef lose at this point and win at the end by putting the characters which are not p, because first of all we have to give preference to p. And at each point we have to check that if we are putting p here and letting the chef lose, then are we left with the required amount of positions in order to score the required amount. That we have to check at each particular index. Fine. And in this manner we will be calculating the optimal choice for each particular point. Fine. For that we have to maintain three things. First of all, a remaining variable which will be denoting that how many indices are still left, so that we can let the chef lose at this point, and we can gain the required score from the remaining indices. That will be denoted by remaining, and initially it will be equals to n. After that we have to maintain a score variable which will be telling us that what is the current score of the chef that has been scored till this point. So we have to maintain a score variable which will be telling us that the current score of the chef, which is going to be initially as 0. And the third thing that we have to maintain here is required, that what is going to be the required score at till this particular point. Let's suppose we are letting the chef lose at this point, okay, by putting p here, and the required score is going to be 4, and the remaining indices beyond this index is 3 only. Then we will not put p here and let the chef lose. We have to put a optimal move which is going to be r. Means we have to let the chef win at this point, because we are not left with enough indices to score the required amount. So we have to put whatever is going to be here in order to let the chef win at this point. Fine, whether it could be r or s. Okay, so that is going to be maintained by the required variable, and the required will be equals to n by 2 plus 1. This is going to be the required minus the current score, means the score that has been already scored. So this is going to be the required score, that at any particular point what is the score that has been required. And for any particular index, let's suppose for the ith index we are placing p here and the chef is losing at that point. So we have to check that if the remaining is greater than or equals to the required, then only we will put p at that index and let the chef lose, so that we can cover the score on the further indices. But if the remaining is less than the required score, then we don't have to place p here. Okay, we have to place the optimal move here, means r or s. In this manner we have to just simulate the process by maintaining these three variables and putting the optimal choices. First of all, try to put p, and if the chef is losing, then let him lose, and check by these three variables that whether we will be covering all the remaining score from the further indices or not. Okay, and if that is not possible, then put r or s, whatever is required here. And in this manner iterate over all the indices and place the optimal character that is going to be for that particular index. And yeah, that's all about this, and get an AC verdict.